Welcome to the Mosfet lecture series. So far, whatever the things that we saw, I hope you all understood all those things. If you are really understanding all these lectures, don't forget to click that like button and share it with all your friends. Okay. So in this lecture, we are going to look into the next question. So given it is transistor T1 and T2 have their sold voltage Vt equal to 1 voltage and the value of K1 is defined as 36 microampere per whole square and K2 is defined as 9 microampere per whole square. Then what is the value of V0? So this is the value of V0 here. We have to identify the value of V0. Okay sir. Now what is this K1 and K2 and how to calculate the value of V0? So that is our next target, right? So apply your mastermind, try to bring out the answer. Just to pause the video, I have taught already, I have given all type of concepts, whatever the things that are required for this question. So you can try to bring the answer. If you are not getting the idea, then look into the solution, okay? So let me proceed further with this question. First thing is, let me take the transistor T1 and I am calling it as current through this is ID1. And I am taking the second transistor, I am calling it as current through this transistor is ID2. Next thing is, current will always flow from drain to source and I also know current through the gate terminal is always 0 ampere. So from here there will be no current. Okay sir. Now understood one more thing. If there will be no current through the gate terminal, so from here also we will be observing the same ID1. Yes sir. Same ID1 will be going from drain to source. So this source terminal also will be receiving same ID1. Then this source terminal is connected with the gate terminal, drain terminal of the next transistor. Yes sir. So this is the drain of the second transistor. Now if you observe, drain of the second transistor, source of the first transistor are same only. So whatever the current that is coming here, same current will be entering into the second transistor. Sir, observe here there will be no current, it will be 0. So this current will be finally entered into entering into the ground. So I can call it as, from this, what is the conclusion? ID2 and ID1 both are equal only. Both transistors are going to carry the same current. Okay. Now from here, I am also going to give you one more conclusion. What is that conclusion is, always, whenever the gate terminal and drain terminal are short circuited or shorted, not short circuited or shorted together, then always the transistor will be in saturation region. This is observation. It is not mandatory condition. It is actually observation. Whenever you are observing that gate and drain terminals are shorted together, then the region of operation is always saturation. So now if you observe, they have given two transistors. If you take the first transistor gate terminal and drain terminal, both are shorted together. Yes sir. Similarly, the second transistor also, gate terminal of the second transistor and drain terminal of the second transistor are shorted together. So the conclusion is, both the transistors are going to be operated in the saturation region. That is the next conclusion. It's nice, right? Yes sir. So just to do, remember this. Sir, if you want to cross check, you know how to cross check, just to do it. That is your choice. And the next thing is, we concluded that the value of ID1 and ID2 both are equal. From here, what we are going to do? The question is, we need to explore the value of V0. Yes sir, we have to explore the value of V0. So let me tell you few more things. From the transistors, let us define all the parameters one by one. First I will write the expression for ID. In the saturation region, what is the generalized expression for the current? In saturation region, the generalized expression for the drain current is, it can be defined as mu n C ox omega by 2 times of L into, in bracket, VGS minus VT whole power 2. Next, from here I can see always whenever, if there will be some constant is given with some value and the unit is in microampere per volt square. See, if it is in ampere per whole square, then actually that K is talking about mu naught C ox omega by L. Don't forget that, because let me define mu naught, mu n C ox omega by L unit will become ampere per volt square. Okay, now here they have defined it in microampere because that current is in microampere, that's why it was given in microampere. Okay, fine sir. Anyway, the conclusion is K is talking about that mu n C ox omega by L only. That's what I would like to conclude. From this I can say this can be further defined as K by 2 into VGS minus VT whole power 2. I hope you all understood this. Okay sir, suppose if you are having two current, then how can I define that? If you are having two current, then the first current it can be defined as K1 by 2 into VGS1 minus VT whole square. For the second current it can be defined as ID2 equal to, you can define K2 by 2 into VGS2 minus VT whole square. Yes or no? It is very easy. From here, let us proceed further. We know ID1 and ID2 both are equal to each other. Already we have been explored that the value of ID1 and ID2 both are going to be equal to each other. So I am just equating them. K1 by 2 into VGS1 can be written as VG1 minus VS1 minus VT is already presented there whole square equal to, what about the value of K2, ID2, that can be written as K2 by 2 into, this can be further written as VG2 minus VS2 minus VT whole power 2. Now I think the value of VT is already given in the question. Yes, the value of VT is given as 1. So you can substitute in place of VT, you can substitute 1 volt. In place of VT, we can substitute 1 volt. Now we have to calculate the value of V0 only, right? So let us come back to the question. See, where it is fixed, actually V0 is nothing but, V0 is connected with the source terminal of the first transistor and gate terminal of the second transistor, of course drain terminal of the second transistor. Yes or no? These all parameters are at a single point it is available. So all are equal only. From this I can say VG2 can be replaced by V0. Yes sir. What about VG1? Let us see. VG1 is connected with VD1. So I can say VG1 is equal to VD1. Both are short circuited. Of course it will be equal to VDD. VDD is how much? That is given as 5 voltage. Now from the question, did you observe or not? It is in the diagram. See there, here. You have to observe. Okay sir. So the value of VDD, or I can say the value of VG1 is going to be 5 voltage, and see there I told you VS1 equal to gate terminal of the second transistor. Of course this will be equal to drain terminal of the second transistor, that is nothing but V0. So in place of VS1 I can substitute V0. Okay sir. So now what is the other unknown parameter? VS2. What is the value of VS2? That is source terminal of the second transistor. Source terminal of the second transistor is directly connected with the ground. So ground means this value is going to be 0. So now you can substitute in place of VS2 is 0. And you also know the value of K1, K2. It is given in your question that the value of K2 is 9 microampere per whole square. This is 36 microampere per whole square. So in place of K1 I can substitute 36 microampere. In place of K2 I am going to substitute 9 microampere. But if you compare both LHS and RHS, let me compress this. So from here I can say the conclusion. See there, this microampere will get cancelled on both sides. Yes sir. 4 times of 9 will give you 36. Yes. This 2 will get cancelled on both sides. So finally it will become 4 times of, in bracket we are having 5 minus V0 minus 1 whole square equal to, here we are not having anything. This is V0 minus 0 minus 1 whole square. Okay sir. Now what I am going to do is, I am just going to cancel this square on both sides. How do I do this? I am going to take the square root on both sides. I am going to take the square root on both sides such that this square will get cancelled. Square root of 4 will become 2. So 2 times of 5. See, I can reduce this. 5 minus 1 will become 4. We can directly substitute here. This will become 4 minus V0 equal to V0 minus 1. From here further it will become 2 times of 4 will become 8 minus 2 times of V0 equal to V0 minus 1. Now pass this minus 2V naught to the right hand side, bring that minus 1 to the left hand side. If minus 1 will come to the left hand side, it will become plus 1. If minus 2V naught is going to the right hand side, it will become plus 2V naught. So V naught plus 2V naught will become 3 times of V naught. Finally 3V naught will become equal to 9, and the value of V naught will be equal to 3 voltage. Yes sir, successfully we have been explored the value of V naught. So anyway what we are always surrounding with the formula that I had given. That is what I am telling. If you remember whatever the things that I had given, that will be sufficient. And I am giving you one small homework. Take this circuit, check whether the condition that I told you is getting satisfied or not. I have been directly written the conclusion that whenever in a transistor gate and source terminals are gate and drain. Gate and drain means, see, transistor is always be like this, and this is source terminal. If this gate terminal is connected with a shorted with the drain, this is drain, this is gate. If it is shorted like that, then that region of operation, this transistor will always be in saturation region. That's what I concluded, right? You can just cross check for this circuit whether it is correct or not. Okay, so this is all for this lecture. Remaining things we will see in the next class. Thank you all.